All right, let's take a look at example 2 over here. You have two cables, we'll call it cable A and B, and they're suspending a 100-pound object. Okay, so it's stationary. The cables are at different angles with the horizontal. And let me make my horizontal over here. We'll say this one makes a 35-degree angle, and then this other one right here makes a 42-degree angle. Okay, so this is your classic tension word problem. The question is asking you to calculate, what is the tension, right? Or what is the magnitude of A? What's the magnitude of B? All right, so here are some key physics concepts. Key concept is that the sum of the vertical forces is equal to 0, and the sum of the horizontal forces also equals 0. Okay. In order for this object to be stationary, all these forces basically need to cancel out. All right, so I'm going to go over each concept and I'll write an equation for each one. Okay, so in order for us to have vertical and horizontal forces, right, we know that these two vectors right here, A and B, just think of them as vectors. Any vector, right, can be written in terms of its horizontal vertical components. So I'm going to label this guy right here pointing in the upwards direction. I'm going to call this guy A of Y. And I'll pretend, right, this is the X and Y axis, or this will start here, the origin. If that's A of Y, this guy right here is A of X, and it's going in the negative direction. Okay, so we'll call this actually negative A of X. And then also over here, we have B of Y, right? This is B of Y going upwards, and of course, B of X is the horizontal component. Okay, so, and of course, you have this 100-pound object, right? This 100-pound object is going down, right? This is mass times acceleration, okay? 100 pounds and it's going down. And so let's take a look at concept number 1. The sum of the vertical forces have to equal 100. So A of Y is going up. So A of Y plus B of Y, right? Both of these guys are going up. Here's A of Y. Here's your B of Y. These forces are going up. And then you have one force that's going down, right? They have to cancel. So this one force that's going down is 100 pounds. So minus 100 is equal to 0. So there's key concept number 1, right? I have two forces, AY, BY, going up. One force, 100 pounds, going down. These guys need to cancel out to 0. If I add the forces, they have to equal 0. Why does it have to equal 0? Because remember, this object is stationary. All right, so equation number 2, the sum of the horizontal forces also has to equal 0. So notice I have A of X going this direction on the left, right? And this is the origin. So by convention, if I'm going to the left, that has to be negative. So negative A of X, and then this B of X right here is going to the right. So plus B of X is equal to 0. So that will satisfy equation number 2. And so what's the point of this problem? What am I trying to do again? I'm trying to calculate what the magnitude of A is and what the magnitude of B is. Okay, so that's all there's to it. Now let's get down to the detail, right? We need A and B in our equation. Right now we have just the horizontal vertical components. The rest is just writing equations and substitution, okay? So for us to get A of Y, right, I would write sine of 35, right, is equal to A of Y over A. Hence, A sine 35, right, the magnitude times sine 35 will give you A of Y. And likewise for B of Y, you would say sine of 42 is equal to B of Y over B. And B times sine 42 will give you B of Y. And what you want to do now, right, is substitute into this first equation. Okay, so A of Y is A sine 35. B of Y is B sine 42. Right, and then I'm just going to move this 100 over here, okay? So do the same thing for equation number 2. How do I get A of X by itself? You can say cosine, right, of 35 is equal to, I'm just going to use this positive A of X, adjacent over hypotenuse. So hence, A cosine 35 is equal to A of X sine 35, right? Oh, sorry, sine 42. Let me erase that. Sine of 42 is equal to, sorry, actually it's cosine of 42. Getting ahead of myself here. Adjacent over hypotenuse, b of x over b. Okay, so b cosine 42 is equal to b of x. Okay, so perform the substitution for equation number 2. This will be negative a cosine 35 plus b cosine of 42 is equal to 0. All right, so at this point, what I would do to solve this equation is I would use substitution. Let's get equation 2. Let's get b by itself. Okay, so b cosine 42 is equal to a cosine of 35. If I get b by itself, that's a cosine of 35 over cosine of 42. And in order for me to do a substitution, I'm going to take this equation right here and substitute into equation number 1. So you have a sine 35 plus a cosine of 35 cosine of 42 sine of 42 is equal to 100. Now I want you to notice something here at this point after I substituted, right? Sine over cosine of 42 is just tan 42. I'm going to factor out this a, so if I factor out this a, it will be cosine of 35, tangent of 42. This just saves you one less button to enter on your calculator, basically. And after I factor out the a, right, get a by itself, you'll get 100 over sine 35 plus cosine of 35 tan of 42. And finally, you can enter this on your calculator. Make sure you're in degree mode. And if you enter it, you should get 76.26 pounds. Okay, and then to get b, right, you take your a value and plug it into here. Your b, the tension, should be around 84 pounds. Okay, so, just really quickly, let's take a look at the concept. Notice the angle, right, that's greater, 42 degrees. My B, the tension in rope number B, is 84 pounds. So you'll find this to be true. The greater the angle at which it makes with the horizontal, the greater the tension of a cable or a rope. And if you think about it, right, it makes sense, right? Let's say this 42-degree tension or rope or cable B gets closer and closer to the vertical, right? You can even think about how intuitive that is, right? The steeper the angle, if you will, the greater the tension. Okay, so that's why B has a greater tension than rope A or cable A is because it has a greater angle, right? 42 degrees, bigger than 35. Hence, it should have a greater tension.